Hello and welcome to Notes 3.3, where we're going to discuss sampling methods. So we, at this point, have already talked about how do you collect data in a way that can be meaningful. And then at that point, what are some things to avoid? Plan ahead and avoid what sort of things? So these methods we're going to discuss today are going to help us also avoid those biases that we talked about in the last video. So we're going to revisit that same context. We're going to talk about that. We're looking at Fremont High School is looking to figure out what is their student population opinions on adding more gender-neutral bathrooms on campus. So we're going to discuss some of those different ways that we can get what we call as we talked about last time, representative sample from that whole population. Now, in an ideal, that's a typo there, I should just say ideal scenario, we could just simply survey the whole Fremont population. The whole student population, all 2,000-ish of them. That's what we call a census. It's a word you might be familiar with because it's something that the United States tries to do, I think, every 10 years. They call it the census. It might not actually be a census. I'm pretty sure it's not because that's literally when you survey the entire population. So we could try to do that. That's not always possible. Even in this scenario, you think like 2,000 people, like how hard is that? But the thing is like the population is actually changing day to day. Like every week at Fremont, whether you know this or not, there are students who leave, move away. There are students who get added on. So the moment you actually do grab a census, it's probably actually not a census anymore like the next day because students leave, students enter. So what we want to do instead is sort of think about a sample. We talked a little bit about this multiple times throughout the year, and here now we're going to sort of lock it down about different ways of collecting a sample that could be representative of your population. So we can look at a population, which is, of course, the whole group that we're looking at. And so we, as statisticians, we're all statisticians. This is what we all want to learn about. This is the group we want to know more about, whether it's just 2,000 Fremont students or it's 2 billion people in the world. We want to know about them. And so in order to do that, usually what we do is we take a sample, which is just a portion of the whole population, and we try to examine it and analyze it a bit to try to help us figure out what's going on with the population. So we've discussed a little bit about parameter versus statistic. Here we're going to really lock it down here. So a population parameter, okay, is what we call the numerical attribute. So it's a number that we're interested in for the whole population. It could be average height, average weight, average exercise time, average study time. Those are all things that we very much attach to like numerical. But it also can be about sort of the opinions, yes or no, agree, disagree, or whatever about things, because we can talk about a proportion. So we can look at it this as a way like, what's the proportion of a population that agrees or says yes to or supports. That is also a way to change something that's a little more categorical into a numerical attribute. And so we usually don't know this. Like if I asked you like, hey, what do you think the entire United States opinion is on gender-neutral bathrooms? That would be a very difficult metric to try to tackle because there's hundreds of millions of Americans. Even if I said like voters or, people above the age of 30, we're still talking about a huge number of people. And so it's not possible to just go and ask all of those people. What we need to do is we need to talk to a sample about this. And so we can grab a sample statistic, and from there we can do something that's called inference. We can infer what the whole population believes based off of this sample. If we do a very bad job at collecting the sample, then our inference is flawed from the get-go. We've discussed this in the biases. What we want to do now is talk about ways we can make sure that we try to get a sample that actually is reflective of the whole population. So we feel good about, like, the sample says 34%, so we can say most likely population is saying about 34%, give or take. And the give or take will happen in second semester. So for this context, our population is all FHS students. That's what we're trying to sort of gather here, is all of them, okay? But our sample is only going to be a subset of these FHS students. We choose not to try to get all 2,000 students. And we have a goal in mind. We're trying to estimate this population parameter. The population parameter is like, what do all Fremont students think about gender-neutral bathrooms, adding on more? Let's say that's what it is. The proportion of all FHS students adding gender-neutral bathrooms. All right. What we're going to do is, though, we're going to grab a statistic, a sample right here, and from there, we're going to just grab and be like, oh, we're going to look at this sample proportion. Remember, that's called p hat. Oh, that's like a tilde. There we go, p hat. Sample proportion who want more gender-neutral bathrooms. And so again, like I think that it's fair to say that whatever sample we do grab, even if it's with the best intentions and we do a really good job at it and we're following the rules and all that, I'm going to have a hard time saying that whatever the sample's proportion is a perfect reflection of the whole population, because there's sampling variability. So we know that that's not going to be possible. And so that's where that give and take I sort of talked about, like they might come out and say this percentage from the sample plus or minus this amount, though. Margins of error. Those are things we're going to lead to in the second semester. But for now, let's focus in on sort of how we could do this. Now, one thing we would do want to do before we ever collect a sample is think about how many people do we want to sample. So there's some limits here. We know we can't grab too big of a sample because the less than 10% condition that we discussed last unit puts a hard cap on, like, you can't grab too much. So we're a little over 2,000 in our school here. And so we know that we can't grab more than just 10% of a little more than 2,000. But we also know that if we're trying to actually maybe do some analysis on our sample, then the central limit theorem also kind of gives us a lower cap. Now, this isn't always possible. Like, sometimes you might not have the option to sort of like be like, I'm going to poll this many people. Sometimes there's limitations. But in this example, we're going to be okay. We know we can't sample more than 10% of the just slightly over 2,000. And we know we want to try to hit that 30 mark because of the central limit theorem. The good news is that I know there's over 2,000 people, and I'm going to say let's go ahead and survey 200 Fremont students. So the last important detail here that maybe was completely obvious to you at this point was that we want to grab a sample that is random. Excuse me. So we as humans are terrible at being random. So in order to do this, what we want to do is actually use a random number generator like a random.org or a random number table that would help us out. So let's look through 4 different ways of collecting a sample of 200 students from our full population here. The first one has this great name. This is called a simple random sample, SRS. It is the most fundamental way of sampling. So what we do is that we think about like, all right, we need everybody to have a fair chance at getting picked. Like if we have this whole population, what's a way to do this? There's ways to actually mess that up very quickly. For example, as noted here, it's like, what if I said, all right, I have all of the lower class persons, freshmen and sophomores, and upper class persons, juniors and seniors. Split them into 2 groups. I'm going to flip a coin, and after I flip my coin, I'm going to randomly choose either 100 or 200. It says 100. I'm going to change that to 200. There we go. So I'm going to randomly select 200, randomly selected lower classmen or upperclassmen. That's not quite fair, right? We wouldn't get a representative sample. Like polling 14-year-olds is different than polling maybe 18-year-olds. And so this, even though it gives everybody an equal chance, is not quite what a simple random sample means. In a simple random sample, the key here is that every combination of individuals in the population has an equal chance of being selected. And on top of that, having an equal chance and on top of that, each individual has an equal chance at being selected, okay? So this means that the chances that you in your group that you're hanging out with right now being selected within the sample is just as equally likely as you and 3 other people in this classroom being selected. But we'll all have an equal chance at being selected. So this is done by assigning a number, a unique number, to each individual and generating in random numbers to select this sample here. So the classic example of this is like we just write down the student ID number for every single student in the class on a little strip or in the school on a little strip of paper, and we put them in a giant bucket, and you just rummage around with your hands here. That's a little annoying. Like we probably don't want to do that. Maybe isn't the worst thing in the world, but what I want you to actually do right now is access back your memory here about how to use a random number table. Do you remember that from our simulations stuff about the hiring discrimination? Take a moment and think about, all right, If we have, let's say, exactly 2,000 students, okay, we're going to go with that. Exactly 2,000 students. Then, how would you use a random number table in order to select 200 students? Think about that and write down your process here. All right, let's move on to the next one. Stratified random sampling. Stratified random sampling. Okay, so sometimes a population has what we call subsets. From an evil, like an obvious factor that can somehow affect these things. So if you're surveying, let's say about monthly expenses, right, to the whole American population, let's say, like a younger person might have different monthly expenses than an older person. So if like you were to grab so let's say like 40% of the people in your population are on the younger side here. Let's say under 30 years. 60% are above the age of 30 years. If you were to do an SRS, there's a chance you might get a lopsided sort of ratio there. It might be that there's 75 people that are on the younger side in your sample. Or maybe the other way. What if there's only 15 younger, 85 older? Then like your SRS sample has a little bit of a problem here. So what we can do is we can sort of separate our population into two or even more, if need be. Am I spelling this right? I am. Homogeneous strata, where the name comes from. Stratified random sampling. So we could go younger and older, and then we can use an SRS to sample, we'll say, 40 younger people, 60 older, because that matches the original proportions that we knew about the population. In order to obtain a relevant proportional sort of sample here. So the purpose of this stratified sampling is to produce samples that have far less variability. Because with an SRS, a simple random sample, there's going to be a lot of that. It's kind of free will on that one. And so we get a more likely chance at sort of getting the population's sort of breakdown matching our sample breakdown. So yeah, in stratified random sampling, like what we want to do is we want to make sure that we're thinking about, is there a natural breakdown that we can do here. I just chose 2 different groups here, younger or older. You can go as many groups as you want. So if you were in charge of this whole poll here, you wanted to sample a group of our students, and you thought there was some natural subset of homogeneous. Homogeneous means like that they are similar in a way, where maybe their opinions could be similar in that way. How might you do this? Brainstorm, write down what you think. All right, and then cluster sampling is our next one. This one is one that gets very much confused with stratified. There's a huge difference though, and I hope I can really clarify that for you here. So dividing the population into homogeneous groups maybe isn't always the best call here, or like maybe it's just annoying is all can be. So like, for example, what if you were trying to figure out what's this reading level of this book? You've never read this book before, you don't know. And so you could do a simple random sample here and be like, okay, I'm going to go ahead and I'm going to read the 576th sentence or the 2,482nd sentence. And that would just be super annoying. Even if you did like if you believed homogeneous to be true, it's like, well, what if I just read like the first 10 pages or the middle 10 pages or what, like if you just sampled from there, you're not going to get a great idea of like what's actually happening there. So cluster sampling. So sometimes your population can't divide into these, like samesies groups in a nice way. And then if you're like, great, I'll just use a simple random sample, it could be that it's a little annoying, tedious, time consuming. Like this example here, we're going to go with like, what if you were trying to determine the grade level for a particular book that you've never read before? Well, you could use an SRS and you would come up with a random number table and it tells you, great, go to page 576 or 2,482. How long is this book? I don't know. That's scary. But it just wouldn't be advantageous to do that, like to just jump around. So cluster sampling. So sometimes it doesn't always make sense to actually break up your group into like these little, or the population into these like samesies groups. Maybe it doesn't work naturally. And then sometimes using an SRS, a simple random sample, just ends up being annoying. Like if you thought about, what if I was trying to determine the reading level for a book I've never read before? So if you're like, oh, I can see that it has this many sentences or whatever, and you decided to do a simple random sample and got, the 576th sentence and the 2,482nd sentence, like, that's annoying. You have to count out all those different sentences in order to come up with this. So what we would want to do is maybe just use an SRS to pick a few pages at random and then sample all the sentences on those pages or those clusters in order to figure out sort of what's going on. So what's really important is that these clusters must be what we're calling, instead of homogeneous or homogeneous, heterogeneous. heterogeneous. I don't think that's how you pronounce that ever. But they have to be heterogeneous. So you have to be sort of aware that like the pages you're actually looking at are similar to the other pages in the sense that like maybe there's 4-word sentences and then 12-word sentences, 27 word. Like they sort of vary as you sort of go along. And thus individually sort of are representative of the book at large. That's what you're literally looking for here. So instead of like with the previous example, where I'd be thinking about, I want to grab groups that are samesies and then do little SRSs within those groups. Instead, what I want to do here is I want to separate them all into different groups because I believe the different groups are different. Like they're heterogeneous. They're not similar in any way. They're just different. And then I want to do an SRS on the individual groups there, in which case I can actually not have to sample the whole population, but just grab like, in this example, like just go on like page 576, or sorry, well, I guess, I mean, this sort of works. Page 576 and page 2482, and then just read those whole pages and sort of determine from there. I don't know if this book actually has almost 2,500 pages, but you get the idea. So I'd like you to brainstorm. At our school, at Fremont, can you think of a way to take our student population and to chunk them up into heterogeneous groups and just sample a few of those? How might you do that? Brainstorm and write it down. Okay, to finish up, we're going to talk about something called systematic sampling. Okay, so this is another method that allows us, this works really, really well when you have a list of all of your subjects or your, people you're trying to sort of survey. And so what you do is you randomly select one subject and then follow it up by selecting the next nth subject. So an example of this is testing every 10th part that comes off of a manufacturing line. So if you imagine yourself in a warehouse where they're building, floor heaters. It's getting cold, so floor heaters. And so every 10th you pull off and inspect to plug it in, turn it on, make sure it works, and then put it back on the line. So it's a great idea. The only sort of issue you might fall into here is if the number of items you're sort of looking at could somehow affect what you're sort of seeing. So for example, if the 10th part can't be when the machine gets low on raw materials, so let's say you go and check the floor heater, and that's when every 10th part is when it runs out of a cord element or whatever, and you go to plug it in and it doesn't work anymore. But that'd be a problem, obviously. So you need to make sure that you're not doing it in a systematic way that you're choosing the poorest or best from it all. In our example here, I don't think there's a way to make that sort of happen. But maybe you can brainstorm something like that. So anyways, what you're trying to do is still make it representative of the parts. So we'll talk a little bit about how to mess this up in class. But I want you to think about, let's suppose you have a list of all of the students at Fremont and you want to grab 200. Let's say there's 2,000 students. How do you do that in a systematic way? Write that down. All right, so we are going to look at your answers. You're going to talk about your answers. If you have not responded to these 4, do so. Write something, even if you're not 100% sure that it's correct, because this is what we're checking off and having you talk about tomorrow. And then you'll get to sort of see an answer key or talk out loud about how you would do these different sampling methods in the scenario that we have given. Okay? So That said, we will see you in class and come ready to talk.